Suppose we have 2 points A and B, and let's join in the line segment that joins them. The midpoint of this line is the point that lies exactly halfway along the distance from A to B, and we may need to calculate the coordinates of this point. Let's draw a large right-angled triangle where the journey from A to B is its hypotenuse, and a smaller right-angled triangle where the journey from A to M is the hypotenuse. Now this diagram should make it clear that the x-coordinate of M is exactly halfway between the x-coordinate of A and the x-coordinate of B. Similarly, the y-coordinate of M is exactly halfway between the y-coordinate of B and the y-coordinate of A. So the coordinates of M can be found by averaging the x and y coordinates of A and B. More formally then, if A is a point with x-coordinate x1 and y-coordinate y1, and B is a point with x-coordinate x2 and y-coordinate y2, then the midpoint of the line segment joining A and B, let's call this coordinate M, can be found by averaging the x-coordinates of A and B, in other words, adding them together and dividing by 2, and averaging the y-coordinates of A and B. Again, add them together, divide by 2. In this particular example, A has coordinates 1, 7, B has coordinates 5, negative 3. So if in our example we have an A of 1, 7, and we have a B of 5, negative 3, then this idea we've just described tells us that the midpoint M should have x-coordinate 1 plus 5 divided by 2 and y-coordinate 7 subtract 3, which is 7 plus negative 3 over 2. 1 plus 5 is 6, divide by 2 we get 3. 7 take away 3 is 4, divide by 2 we get 2. And if we check the coordinates of M, then 3, 2 is exactly what we get. I know that in a simple example like this, with a coordinate grid where we want to be able to see everything nice and clearly, it was incredibly easy to see that those were the coordinates of M before we even started. But if you have much larger coordinates, ones where it's not so easy to see on a diagram, we'll have to do it in this calculation way. In this example, we're told that the points A and B have coordinates negative 5, negative 8 and negative 1, 12 respectively. The line segment from A to B, it says, is the diameter of a circle, and we're asked to find the coordinates of the centre of the circle. Wait a minute, everything we've just been doing is a bit about midpoints of line segments. What has this got to do with circles? Well, if we are told that the line segment that joins A and B is the diameter of a circle, that means that the centre of the circle is the same as the midpoint of that line segment. So you often see questions about midpoints expressed in terms of circles. Therefore, if we're going to call the centre of the circle M for the midpoint of the line, then once again we need to take the x-coordinate of the first point and the x-coordinate of the second point and add them together, divide by 2. The y-coordinate of the first point added to the y-coordinate of the second point, divided by 2, the midpoint should be negative 3, 2. And indeed, on this representation, where we actually have the proper coordinates for A and B, if we do check the coordinates of M, indeed negative 3, 2 is what we get. So in this question, we're given the midpoint of a line segment. It tells us that the midpoint of the line segment AB is 2, 7. It tells us that the point A has coordinates negative 3, 10, and it asks us to find the coordinates of the point B. Well, let's suppose that B then has coordinates, let's just call them x and y. We know that if we take the average of the x-coordinates of A and B, in other words, negative 3 and x, and if we take the average of the y-coordinates of A and B, in other words, 10 and y, then that will give us the midpoint of the line segment, which we are told is 2, 7. Now that means that negative 3 plus x over 2 is 2. It also means that 10 plus y over 2 is 7. And we can work on both of these things separately to work out what x and y are. So in the first case, multiplying through by 2 gives us negative 3 plus x is 4. In the second equation, multiplying through by 2, it gives us that 10 plus y is 14. In the first equation, adding 3 to both sides gives us that x is 7. Taking 10 from both sides in the second equation tells us that y is 4, and therefore the coordinates of B are 7, 4.